Hi guys, today I'll show you the code for Matlab code how to calculate the mean value theorem. So let's take a look that the only thing we need is just to enter the function that we are looking for and the interval starting from A and at B. So let me give you like a brief, refresh your memory about the meaning of mean value theorem. Then I'll come back to the code. And don't worry, I'm going to show you the code with really good image. Just a second. Here, the mean value theorem states that if we have a function and that function is differentiable, continuous of course, from A to B, then f prime of C, where C is a specific value of x between A and B, equals to, take a look to the right side. The right side is just the slope of a secant. So this is the slope of a secant. This is f2 minus f1 over x2 minus x1, delta y over delta x. Secant, very simple. While the left side is a derivative. So here, all what I want to say is that these are numbers. This is a number and that one a number, and this is the slope of the secant, while this one is the slope of the tangent, because the derivative is the tangent of the curve. So how these equal to each other, just keep in mind that the parallel straight line, they have same slope, and that's it. I will show you the graph is going to make it really clear the meaning of like that the right side and the left side. Let's go back to the code. Okay, here we start the input the function and input the interval from A to B. After that, define it as a function and then derive that function. Yeah, let me make it clear. It's not that big code, it's less than 50 steps. Okay, and then when I derive it, do some loop here. Hey, for x equal A to B, and each step I make it like 1 per 10,000. So these are the values of x, and substitute these values in the derivative itself here in this step. Okay, so that's the derivative, while I calculate in the previous one here in step 13 the slope of the secant, which is just delta y over delta x. Now this is the if statement here. If the derivative equal to the secant slope, then stop everything. That's what we need. Then we get the value of x. That will give us the x component of the intersecting point of the secant and the curvature, and the rest is just to graph or plot the function itself and the secant and the tangent, all the three. I'll put them in one graph, you can see. I hope you can read this because I get a lot of emails from the previous video says we can't see it clearly. Hope this one is clear. Let's run it. So here what I'm going to write, call the function, I call it mean, like mean value, and put A, for example, equal 2 and 5. I already typed these numbers. Click enter, then it'll ask you to write down the function, then write this function, for example, x cubed minus 5x squared plus x minus 2. So in this interval we need to find we need to apply the mean theorem. I'll discuss the graph in a second. Let me minimize it. Here, take a look. So first we calculate the slope of the secant. It's just delta y over delta x equal to 5, and then the x component of the tangent is 3.69, and the y component of it is this. At the same time we get the, where is it? We get the graph. That's the graph. It's going to explain almost everything here. So yeah, this is the function, and that's the secant, and that's the tangent. All the three equations are there. If you have any question, if you want to modify it, let me know. Thank you.